Day 25, Customer Churn Prediction. In this project, we'll build a customer churn prediction model using a classification algorithm. Example, in this case, we'll use the logistic regression. The goal is to predict whether a customer will churn, which means leave the company, based on various features. We'll train the model using a dataset with customer data such as tenure, usage, and demographic information. I will provide this along with this video. It will be available to download. And let's go ahead, write the code. So first, let's look at the dataset. So I'm in the days 25 folder, and this is the dataset that I have with customer ID, gender, age, tenure, monthly charges, total charges, contract type, payment method, and finally churn, which is 1 or 0, which tells us. And we have a lot of data. Some data is around 500 rows of data that is provided. So I have that. That's what I'm going to use. So in my code, I have nothing right now. So let's start coding. The first thing that we need to do is import the necessary libraries. Now we would need first pandas as PD used for data manipulation and creating data frames. Next, we'll import the train test split, which splits the dataset into training and testing sets. You can get that from sklearn.model selection. Next, you're going to get the standard scaler. This scales features to have a mean of 0 and standard deviation of 1, helping improve model stability. That's why we're importing this from sklearn preprocessing. Next, we need is the logistic regression from sklearn.linear model. And logistic regression model is used for binary classification. That's why we are using it, where we are going to predict churn or no churn. Next, from sklearn metrics, I'm importing accuracy score and classification report. These are metrics to evaluate the model performance. Now, next step is to load the dataset. So I am going to load this dataset that I have, customer churn.csv here, and it loads the dataset into the data frame, which is df, and replace this customer churn to any other data that you have. If you actually have some data, if you're testing along with me, just use the dataset that I provided. Now the dataset should have various features related to customer information and a churn column indicating churn status. You need to have that in your dataset. Just remember that. Next, I'm going to display the first few rows of the dataset by saying df.head. So dataset sample df.head. This displays the first few rows of the dataset to confirm it's loaded correctly. Next, I am going to get a basic data pre-processing where handle missing data, if any. For that, I will use df.dropNA, which removes any rows with missing values to ensure data integrity. Now, further pre-processing may be necessary depending on the dataset characteristics, but this is the basic that I'm doing. Next, let's convert the categorical columns to numeric using one-hot encoding. And you can do that using saying df.encoded pd.getDummies df and pass column, gender, contract type, and payment method. What this does is this will convert the categorical columns to numeric using one hot encoding. So if it's not numerical, it will convert into numerical. Next, I'm going to define the features, which is x df underscore encoded, and I'll drop the churn in along axis 1. So that will get me the features. And for the target, I will say y equal to df encoded churn. So I'm going to use churn as my target variable. Next step is to split the data set. So split the data set into training and testing. We've done this multiple times, and I'll use the train test split here and allocate 20% of the data for testing by setting the test size equal to 0.2, and I'm using stratified equal to y, which ensures that both classes, churned and non-churned, are proportionally represented in the training and testing sets. And then I'm saying random state equal to 42, which sets a random seed for reproducibility. Next thing is feature scaling for numerical stability. So for that, I will use scalar equal to standard scalar, which standardizes features to have a mean of 0 and a standard deviation of 1. And then I will fit the transform xtrain and have the new xtrain, which calculates scaling parameters, mean and standard deviation on the training set and applies proper scaling. Then next again, I'll use the scalar dot transform x set. This applies the same scaling parameters from xtrain to the test set for consistency. Next, let's go ahead and initialize the logistic regression classifier by saying model equal to logistic regression. Now, logistic regression, this initializes the logistic regression classifier, which is commonly used for binary classification tasks like churn prediction. Next, let's train the model by saying model.fit equal to x underscore train, y underscore train. The fit function trains the logistic regression model on the training data of x train and y train, learning the relationship between the features and the churn status. Next, let's make predictions on the test set. So for that, I'll say ypred equal to model dot predict x underscore test. So this uses the trained model to predict the churn status for customers in the test set, which is x test. The predictions ypred indicate whether each customer is classified as having churned or not. So that brings us to evaluation of the model. So for evaluating the model, I'll first use the accuracy score, pass at ytest and ypred. This calculates the accuracy of the model, which is the percentage of correctly classified customers in the test set, and that will be assigned to my accuracy. And for report classification report, I am passing ytest, ypred, and zero division equal to 1, which generates a report including precision, recall, and F1 score for each class. Now that is the churned and not churned. Next, I'll print it out, print accuracy, print the classification report. So this will print out accuracy, which will show the overall percentage of correctly classified samples, and the classification report will show me the metrics like precision, recall, and F1 score for each class. So let's go ahead and run this thing. I'll go back to my here. I'll see if the file is there. Perfect. Python day 25 py, run it. And here you go, the first few head of the data set. We asked it in the line number 12. That's what is printed here. Accuracy is 0.69. Our classification report, which shows our precision, recall, and F1 score and support for each and every field, is displayed here. So it looks pretty good. And that's how you can predict the customer churn prediction using logistic regression. So I hope you were able to follow along. If you had any problems, let me know and I'll get back to you.